Hi Algebra 1, this is the video for 3.7 Graphing Absolute Value Functions. You'll find this in your yellow packet. You might just have to flip a few pages. This is our next section. I know it says chapter 3, so we're going back to a section that we skipped. And now we'll talk about absolute value functions. They're going to look a lot like parabolas, a lot of the same characteristics, except for their shape. So let me first show you what the shape of an absolute value is going to look like. First of all, the parent function will be y equals absolute value of x, and you'll see the x will be inside the absolute value bars. And I'm going to make a little table of values just to show you what these points will look like. If I plug in -3, the absolute value of -3 turns positive. Same way for -2, that'll turn into +2. This will turn into +1. The absolute value of 0 is 0. The absolute value of 1 is 1. This will stay 2, and this will stay 3. And so if I plot these points, -3, 3, -2, 2, -1, 1, 0, 0, it's going to start to look linear. But then after 0, 0, we'll bounce back to +1, 2, 2, and 3, 3. And so it makes a V. But you'll look on either side of the V, and there are straight lines on either side of that vertex. You can also look at the chart. Do you see how I'm just subtracting 1, but then all of a sudden I'll start adding 1 when it bounces back up? So it looks a little bit like a parabola, except it is a straight V. But like I said, the characteristics will be the same. The A will tell you if the A is positive, then the V will open up. If A is negative, the V will open upside down. The vertex will be at HK. You'll still change the H. If it says negative, you'll change it to a positive, and vice versa. Your axis of symmetry will be the same as it was for the parabola, so that first value in your vertex. To find the y-intercept, we still have to plug in 0 for x. So a lot of that is the same. Also remember, if I go too fast, you can always pause the video and you can go back if you need to hear something again. Let's go ahead and look at these examples. So is A positive or negative? Remember, A is that number in front, that leading coefficient. It's positive, which means our V will open up. The vertex is at +3, 7. Again, remember, you'll change that from a -3 to a +3, and axis of symmetry is at 3. This is negative, so it opens down. The vertex is -4, 0. Axis of symmetry, -4. This is positive, so that means it opens up. Vertex is at 0, -5. Axis of symmetry is at 0. So all of that should look familiar from parabolas. So now the y-intercept, we're going to plug in 0 for x, -1/3, absolute value of 0 minus 3. Now 0 minus 3 is -3, but because of the absolute value, that should turn into a +3. The -1/3 is on the outside. Now the absolute value turned that into a +3. A third of 3 is 1, so I should get -1. And so 0, -1. Let's do it again. 3, absolute value of 0 minus 2, and then -1. Again, the -2 will turn into +2. Order of operations tell me I need to multiply, so I'll get 6 minus 1, which will be 5. And so 0, 5. And one more time, let's just plug in 0. Absolute value of 0 is just 0, and 0 plus 4 will be 4. So 0, 4 will be the y-intercept. Let's check out this graph. This is a parabola, so I'm going to erase B. It can't be that one. This shifted to the right, and so I should see a negative in my absolute value, so that can be the only answer. Also, this tells you that it shifted up, just like the other shifts on the parabolas, so definitely we went right and we went up, so it has to be C. And let's just do a couple of these on the next page where we actually graph them. So the H is -4, the K is -3, so the shifts are, left 4 and down 3. the vertex will be -4, -3. Axis of symmetry, x equals -4. Is A positive or negative? It's positive, which means it opens up. And then the y-intercept, if I put in a 0, I'm going to get 4 minus 3 would be 1. So 0, 1. So again, the vertex is at -4, -3. If you want to make the axis of symmetry, you can. The y-intercept is at 1, and I can just mirror that over, and then I can make the V. And I'll show you another way you can make your V. Because these are straight lines, this number in front, this A, think of that as your slope of those two lines. So the slope is 1, so I can go up 1 over 1, up 1 over 1, just like I would with a normal line, how we did with the linear functions back in first semester. I can use the slope to graph my V if I wanted to. Let me show you that here. So this should be +1, 0. I would have gone to the right. Because of the 2, this should also be narrow. Vertex 1, 0, axis of symmetry at x equals 1. This is positive, it opens up. When I plug in 0 minus 1, I get -1, but remember that turns positive. So I have 0, 2. Let's put our vertex in there at 1, 0. So you can see that it moved to the right 1. And let's use our slope. Let's try to do that. So if our slope is 2, we'll go up 2 over 1, up 2 over 1. We can go the other way, up 2 over 1 in the opposite direction, and we can make our V that way if we wanted to. By the way, domain, all real numbers. Forgot to do that up here. Range will still be y is greater than or y is less than. Since this one opened up, it'll be greater than -3. This will be y is greater than 0. Let's do one more. The h is 0, the k is -1. It shifted down 1, and this one should be reflected. Vertex 0, -1. Axis of symmetry was x equals 0. The a is negative, which means it opens down. So upside down like this. Sorry, I made a parabola. So V, upside down. The y-intercept, we're going to plug in 0 for the x. -0 is still 0. -1 should be -1. So our vertex is at 0, -1. And our slope is -1, so we should go down 1 over 1, down 1 over 1, down 1 over 1. And then you can make your V. Domain, all real numbers. Range, y is less than or equal to -1. Go ahead and start your assignment. It's in the green packet. It should be section 3.7. And then I will be back tomorrow to go over any of your questions, and then we'll go from there. Thanks. Have a good day.